attention that I'll give you exact steps that you need to do. And that is your assignment for next week. So you're going to only cover activity on ARC. So that's what we're going to cover. Okay, activity on ARC, you can say we have an activity I, an activity J that you're connecting it through this ARC. Okay, we are using this is paired favorite method. That's when you can start an event, correct? And it take maybe 3 days to finish this event. So it's called activity on node and activity on ARC. Okay, this is activity on node. This has another name called activity oriented network or precedence network. So that's another name for it. This is more popular for CPM. Okay, so these are two different activity. Activity on ARC and activity on node. So this is activity A on ARC, activity A on node. So that is how you can visualize it into your mind. Now we go to define algorithm that is used in each network, activity on ARC and activity on node. So we need to understand this algorithm. Okay. Activity duration, it could be deterministic, as in CPM method. So you have some experience, you have done some work in the past, you know how many days it's going to take. Or we mentioned last time that it could be probabilistics, means that in paired method, you basically don't have a clear idea how long it may take to do an activity. Then you use this expression. That is something that we discussed last week. Okay, time estimate. We do some on probability. So use some heuristic method and do some guessing and calculate your activity based on this most optimistic, most likely, and most pessimistic. So that's how you can do it. So this is an example of our WBS that we have developed. We have activity A, B, C, D, E, F, G, H, I, and it shows the predecessor, and we have calculated the estimated time. Any question on these? Okay, so this slide is already on Canvas. So our objective is to develop a time schedule using activity on ARC network. So how do you do it? You basically look at this table and transfer this table. This is activity A, first activity you need to do. What is a predecessor? None. Duration 2 days. So that's how you can do it. Say activity A, it is right here. Activity B is right here. It takes 2 days, 3 days, and then this is C, and then there is activity D, E. So you label them. You develop your network like this. Okay. So this is called source node, correct? This is called source node, and this one is called sink node or end node. That's a beginning node and that's an ending node. Look at activity D as both A and B as a predecessor. Activity D as A and B as a predecessor, correct? So we added dummy activity here because there is no connection from to this node. Then you do a dummy activity and do it with the dashes. You do it with the dashes. So this is called a dummy activity because activity D has an A and B as a predecessor. Okay, but since there is no connectivity between here and here, you do a dummy activity. Similarly, activity I has an F, G, and H as a predecessor. So since there is no connection, you do another dummy connection over here. So can you make your project network so far from your table?
Yes.
All right, it's straightforward. You basically transfer all this information to this network right here. Okay, and then critical path is our objective. You need to find a critical path, see which activities are critical that you need to pay attention. So what is the critical path? It is the longest path. It's the longest path into your network. So basically, once you solve your network, you can find the longest path and say, okay, this project, it take me 1 year to do it, 2 months to do it. So that's how we can look at it. So this is used by project manager for controlling the project. That is how project manager look at project network and continuously monitoring the critical path, making sure everyone is doing their work. So how do you develop critical path? That's three different methods that you can do it. Method one, method two, method three. So we're going to look at this is kind of not popular, so we're not going to use this one. We're going to concentrate event-based computation activity on arc and activity-based computation on activity on node. These are two most popular ones. These are good. So that is what we're going to do. So the first thing that you do, it is basically the first step in solving your network, like the way that you develop your topsies. Here we need to develop or solve our project network. So the first step it is to node numbering. So you put node number 1, 2, 3, 4, 5, 6, 7, 8, and it is important that you node number them in sequence. Don't randomly put numbers. Like you start from here, 1, then you go 2, 3, 4, 5. So you just put some sequence to node numbering them. So our goal again, we do all these things because we want to find the longest path or the critical path. Okay, that's our goal. See how we can achieve our goal. The first step is to node numbering. So that's how we can do it to find our critical path. We're not going to use this one. This is path enumeration. Basically, you look at your table and start from node number 1, the successor for node number 1 or node number 2 and 3. So you start from level 0, then level 1. You basically transfer all this information from this table in here as such. But this is not our desired approach. So you do all this, and then the end node, you basically checking it like this, checking this is our end nodes, and goes to level 7, level 0, level 1, level 7. But this is going to be for a big project, it's going to be very complex. So if you look at this formula here, n is the number of node number. We have single source and single sinks. So the upper bound, it is basically 2 to the power n minus 2. Here we have 8 ending nodes, 1, 2, 3, 4, 5, 6, 7, 8. So to the power 6 is 64 path that you need to compute. So for a bigger project, this is going to go out of control. So we're not going to discuss this one. So we're going to discuss event-oriented algorithm activity on arc. So that is our approach. Are you following me so far?
Yeah.
Yes.
We have not started
Yes.
anything yet. All we did, we set up our network based on the information that we have, and now we decided that we're going to use this technique, activity on arc. So here is the starting of our process that you need to pay attention. So we're going to utilize this methodology to solve our project network. What does it mean solving it? It means you need to know some concept. We need to do two-step solution. One is forward pass and one is backward pass. So what is forward pass? That's the first step. That's the first step is forward pass. Once we learn the forward pass, then we do the second step, backward pass, in context of our network, and then we're done. So it's very easy. Please pay attention so you don't get confused when you go to your meeting. You're going to be productive. So this is called initialization step. Initialization step. So E stands for earliest start of your first node. Earliest start of your first node. How early can you finish your project? What activity? I want an answer. How early can you start an activity?
You said how early can you start the activity?
Yeah. What is it? On day
Could be
zero, right?
day one or day zero.
Day zero. So that's why I put day zero here. The earliest that you can activity start activity number one from your project network. This is your network. How early can you finish this activity? Correct? This activity A, how early? On day number zero. So that's why I put here activity one can get start. This is a project starting time. This applies to all source node. So you may have, you have only one source node. Earliest occurrence of first node is zero. So you need to understand this terminology. Earliest occurrence of a first node is zero, and that's how you can show it. E sub 1 is equal to zero. Now, earliest occurrence time of a node, any node, E sub j. So you have your project network consists of big project, correct? Big network. Now we want to look at see how early we can start all these different activities, correct? All these different activities. So how are we going to do it? You can visualize your project network and say this is a subset of my project network right here. This is a subset. So the earliest time that you can start any activity called J, it's equal to maximum of E sub I plus T sub ij for all I before node J for set of B sub J. So imagine I have broken up portion of your network and show it over here. This is fraction. This is a small section of your network that this is your node E sub J. I want to see how early I can start this activity. Okay? It says E sub I plus T sub ij. Earliest start of this successor node. Okay? Successor node. Correct? So E sub I plus T sub ij, you add them. If the earliest start for this node is 3, correct? The duration. And duration for these 2 days, let's say earliest start for this is 5 and the duration is 2 days for this activity. Earliest for this one is 4 and one is 1 days. It says E sub I plus T sub ij. You take the maximum. So what is 3 plus 2? 5. 5 plus 2, 7. 4 plus 1 is 5. So how early can you start this activity here? You take the maximum. You put 7 over here because 7 is the max. You take the predecessor. You pick up any node and you get the predecessor and you add E sub I plus T sub ij. E sub ij is the duration. E sub I is the earliest start of that specific node. So that's you need to learn this logic in order to solve your network. Okay? That's a basic logic. Now I'm going to show it here. This is our network. How early can you start this activity A? Based on this formula, the earliest that you can start activity A, it is 0. Earliest start of the first node is 0. So what do? You put 0 over here. Does it? You follow this? And then you put them in this square. Are you agree with me?
Yeah.
Yes.
And after node number 1, you need to go to the next node in sequence. Which node is the next node? Is node number 2. How early can you start this activity 2? This activity take 2 days. This activity take 3 days. Okay? 2 days. 2 days. Based on this formula, E sub j is equal maximum of E sub I plus T sub ij. So you come here and you see how many nodes, how many arc is coming to node number 2. There's only one. So you have no choice. You say 0, 0 plus 2 is equal to 2. So you put this 2 over here. Which node are you going to go after node number 2? Number 3. How early can you start node number 3? Again, you use this formula. E sub I plus T sub ij of all the successors. So how many nodes are coming to node number 3? One is this node, the duration for dummy is 0. The duration for this one is 3. So which one
Two
you will
nodes.
select? I'm sorry?
There's two nodes. You'd pick the one with that starts on the third day.
You sell them, you pick up the maximum. You basically follow this formula here.
Why is there two arrows going to the third day? Does that mean that we just have to have both 1 and 2 completed before you start the third task?
Yeah, because this node D has a predecessor of node A and B. Node D, if you look at the table that we show over here, node D right here. Node D has a predecessor of A and B. So we decided that since there is no connection between this node and this node to a dummy connection, for dummy connection, there is no 0 activity time.
Okay, thank you.
Okay? So you go in sequence, then you go to node number 3. Node number 3, this one is basically you take the maximum 2 plus 0 and 0 plus 3, correct? So this is 0, 0 and plus 2 days, 0 plus 2 is 2. This one is 3 days, 3 days, and 0 plus it give you 3. So which one is maximum, 3 or 2? 3 is max. You put 3 over here. Then you go to node number 4. How many arcs is coming to node number 4? Only one. So what you do, you say 3 plus 4. 3 plus 4 is equal 7. You put 7 over here. Then from node number 4, we go to node number 5. How many arcs are coming to node number 5? 2 arcs. You pick up the maximum. What is 7 plus 5 or 2 plus 1? Which one is most?
It'd be the 7 plus 5.
7 plus 5. So that will put 12. And then after node number 5, you go to node number 6. How many arcs are coming to node number 6? Only one. Then you say 12 plus 4, it gives you 16. So you put 16. From node number 6, you go to node number 7. How many arcs are coming to node number 7? 3 arcs. You pick up the maximum. This is 0 days. This is 6 days. This is 8 days. So 16 plus 0, 12 plus 6, and 7 plus 8. Which one is the maximum? 12 plus 6, you put 18. Then from node number 7, you go to node number 8. How many arcs are coming here? Only one. What is 18 plus 3? It is 21. So you put 21. So that's 21. You follow this?
Yes.
So it take basically 21 days for you to complete this project. So this is called forward pass. Let me tell you one more time. This is called, we said there are two steps. One step is forward pass. That is an initialization step. And we use this expression right here. Earliest occurrence of any node in your network, it is calculated by taking the maximum of E sub I plus T sub ij, your successor, E sub I plus T sub ij. And that's why we put subset of your network here to explain for you. And then here, that is actual showing the forward pass over here. So this is forward pass. So we're done. Any question on this? So that's called initialization step. There is one more step that you need to do that's called backward pass. So we're going to go to backward pass. Okay, why this is upside down? How can I change this one? Okay. Okay. This is called backward pass. That's the second step. What is the initialization step? In a backward pass, we say what is the latest occurrence of all ending node. So we go to the last node, terminal node, okay? The sync node or terminal node, you look at your project network and you say, okay, what is the latest occurrence of all ending nodes? You may have more than one ending nodes. So you look at what is the latest occurrence of any ending nodes and you label it L sub n. It is equal to project duration, T, as determined in the forward pass. So the latest occurrence of this node, which is called the sync node, it is 21 days. So that's what we're trying to tell. The latest, so we're going to go backward. We're going to start from ending node and do this process, go from 8 to 7, 6, 5, 4, 3, 2, and reaching to node number 1. We do the opposite. How are we going to get it started? We're going to look at L sub n, and that's going to be project duration T. And then we're going to use this formula. Latest occurrence of any node, it's equal to minimum of L sub j minus T sub ij. So we're going to use this formula. This time we're going to take the minimum. And basically, that's how you do it. L sub ij, you see all the node that come into this node, you take L sub j minus T sub ij, and you pick up the minimum. So you have 3 nodes are coming in here. Now let's see how it's happening over here. What is the latest occurrence of your node number 8? Based on our assumption, is the project duration, T. What was the project duration? We decided in forward pass to be 21 days, correct? That's the duration. So the latest occurrence of node 8 is 21, and we put them in this triangle. Are you agree with me at this moment?
Yes.
Okay. Now, which node you going to go after node 8?
You will go to node 7.
You go to node 7. Based on this formula, latest occurrence is minimum of L sub j minus T sub ij. Okay. What is here 21 minus 3.
18.
Yes or no?
Yes.
Yes.
Yeah.
Okay. So which node we're gonna go after node number 8? So you're gonna put 18 over here. So this is basically 21 minus 3 is equal 18. So node number 7. How do you get node number 7? You take the minimum. Correct? We got 18, which after 7 we go to row number 6. What is for node number 6?
So would you use the node, I believe the dummy node, so it'd be the same thing, so it'd be 18. So we're using the minimum.
Yeah. So it is going to be 18 minus 0. 18 minus 0 is equal 18. So you pick up this 18 right here. Which node you go after node 6? Go to node number 5. How many successor node 5 has? This is 1 and this is 1. So you say 18, correct? For two successor, node 6 and node 7. So you say 18 minus 6 is equal to 12. And then you say 18 minus 4 is equal to 12. Correct? So that's why you put 12 over here. Which node you go after node number 5? You go to node number 4. So node number 4, you say 12 minus 5 is equal 7, and 18 minus 8 is equal to 10. Which one you pick? 7. So you put 7 over here. After node number 4, you go to node number 3. Node number 3, you say 7 minus 4 is equal to 3. So you put 3 over here. After node number 3, you go to node number 2. Node number 2, it is basically 12 minus 1 is equal 11, and 3 minus 0 is equal to 3. So you put 3 over here. After node number 2, you go to node number 1, and basically it is 3 minus 3, it is 0. So you put 0 over here. That's a minimum. So that's how you do the backward pass. Everybody follow? Then this is basically activity scheduled from event times. We had one node I, one node J. We realize we have earliest start and latest start for any activity. Duration called T sub ij, and earliest start of this activity called E sub j, and latest start of this activity is this L sub j. So we need to realize that earliest start of an activity ij is equal to E sub earliest start of ij and is equal E sub I. That is something that we did. Early finish of activity ij is equal early finish of ij and is equal earliest start of ij plus T sub ij. E sub earliest start plus T sub ij. That we did in forward pass. and we did this one in backward pass. So that's what we did. Okay. Now, if you come here and take the information from your network and develop this table. It's called early and late schedule. Okay, early and late schedule table is right here. What you do, you put your job A, B, C, D, E, F, G, H. That's how you can construct this table. The duration, you already calculated the duration. You get it from your network. 2 days, 3 days, you come here, put all the numbers, 2, 3 days, and so forth. What is the earliest start for A? Earliest start, it is 0. For B, it is 0. For C, it is 2. So you come back in here, you put everything in a boxes, correct? In a boxes, earliest is 0, is 2, 3. So you copy all this number in this column. Earliest start, correct? Are you following me? That's column ES.
Yeah.
Then you go to column LF that I put it in bold. What is the latest finish for node A? Latest finish for node A. Latest finish for node A is 3. Latest finish for this one, it is 3. You can wait until 3 days. So you put all these things and you fill up the column latest finish from your, what is the latest finish for node D is 7. For node D, it is 7 right here. So you put all this information in column else of F. Now you need to calculate this node, this row, and this row. Earliest finish is equal earliest start plus T sub ij, right here. E sub start, earliest start, it is basically 0. 0 plus 2 is 2. You put 0 plus 3 is 3. 2 plus 1 is 3. 3 plus 4 is 7. 7 plus 5 is 12. 7 plus 8 is 15. So that's how you can calculate earliest finish. How do you calculate latest start? Latest start is equal latest finish minus T sub ij. So latest finish basically is 3 minus 2 is 1. 3 minus 3 is 0. 12 minus 1 is 11. 7 minus 4 is 3. 12 minus 5 is 7. That's how you can calculate latest start. And then the last column, how do you calculate this one? That's a time float. It is latest start minus earliest start. Latest start minus earliest start. 1 minus 0 is 1. 0 minus 0 is 0. 11 minus 2 is 9. 3 minus 3 is 0. 7 minus 7 is 0. 8, correct? And yeah, this one is, yeah, latest start minus earliest start. Latest start is 10 minus 7 is 3. 12 minus 12 is 0. 14 minus 12 is 2. And 18 minus 18 is 0. So this is time float. Time float means that wherever that you see 0, those are critical. Means that you cannot delay that activity because it shows 0. Activity A, you can delay it by 1 day, nothing gonna happen. Activity C, you can delay it by 9 days, nothing gonna happen. So these are the time slack on these activities. So activity with 0, total float, or critical activity. So that's going to be a question in the exam. So you come here and look at all these zeros and look at your network and put those activity in red. So it means that in your network, all this activity are critical. A project manager must pay attention, making sure that all this activity are done on time. And then you basically transfer this information into this Gantt chart. So if you look at this Gantt chart, that's how you put your activities that are critical, like activity B and D and E, correct? These are critical. B and D and E, these are critical activities. Activity C has a delay of 9 days. Activity D has a delay of 9 days. See? C has a delay of 9 days. C, 9 days. So it means that that's how you can do it. Delay of 9 days. You can start it on day number 2, or you can wait and start it 9 days later over here. So this is your Gantt chart. So that is what you need to do and develop your Gantt chart. So activity B, D, E, G, and I with zero total float or critical activities, no float. Any questions? That was our lecture for today. So you have to meet sometimes before next meeting, next class, and develop your project network. And team leader, please let me know if your teammate was absent today. It is your responsibility to let me know.